As we continue our study of exponential and logarithmic functions, in this video we will focus on solving some word problems, some real-world problems involving exponential and logarithmic functions. Okay, now look at these equations that we have here. These are the first two equations are the equations that we use for compound interest. So if we have a compound interest problem, we'll be using one of these two. The other two are for general growth, exponential growth, and exponential decay. All right, so if we have two equations for compound interest, then how do we know which one to use? Well, this PERT formula here is the one we use when we have interest that's being compounded or collected continuously. For anything else, if you are compounding or adding on the interest daily, monthly, quarterly, semi-annually, whatever it may be, then you use this formula. So for number 16, let's see what's going on. You deposit $3,000 into an account that earns 5.5% annual interest compounded quarterly. Okay, so right here you see we're dealing with compound interest. So we're dealing with one of these two. Now, is it the first equation or the second equation? Well, they said compounded quarterly. Alright, that lets us know to use the first equation. We only use the second equation when it says continuously. Okay, so write a model for the investment. So basically we're going to just substitute in these numbers right there. Let's see, I feel like we need a little bit more space in this. Okay, so let's give it a shot. So the amount of our investment is going to equal, now P stands for principal. Principal means the initial amount that you invest. So that's our $3,000. Okay, and then we have 1 plus R over N. So 1 plus. R is the rate written as a decimal, not a percent. So if I move this decimal 2 times to the left, it's going to become 0.055. Okay, so that's my rate. That's R. Now N is the number of times a year that you are compounding. So if you compound quarterly, that means 4 times a year. So N is 4. And then we have N times T. So that's the same N as before when we said 4. So we'll say 4T. Now for the model, that T is going to still be there. We don't know. This equation should give us the amount of our investment after any time T in years. So there's that. Now, how long will it take for your investment to triple? So we're looking for T that will cause our investment to triple. Now, our initial investment is $3,000. 3,000 times 3 is $9,000. So that will be the eventual amount that we will have sometime later. So that 9,000 is going to go right here in the formula. All right, I'm plugging the 9,000 in right there. So the rest of it comes. Okay, and I've got my 1 plus. You know what? I think I'm going to have to change this into a decimal. It's just going to be too awkward to work with without making it into a decimal. But as I do this, if need be, I'm going to make sure to have 4 decimal places. I don't know how many decimals I'm going to get yet. So let's see, 1 plus 0.055 over 4. 1 plus 0.055 over 4. Okay, you know what? I'm going to keep all of these decimal places. 1.01375. Okay, to the 4t power. Okay. Anyway, so let's carry on. Keep all these decimals. All right, if you round now, it's going to throw off your whole answer. Don't do it. So let's divide both sides by 3,000. Of course, so these cancel. So of course we're going to get 3 because we said we tripled it. Of course it's going to be 3. So what we have now is 3 equals 1.01375, okay, to the 4t power. Now we're trying to find t. So the best thing to do now is to rewrite this in log form. So in log form, of course, we're going to have log base, something. Now this decimal number is the base, so I need to write log base 1.01375. Now the rest of it is going to change sides, so this and this will switch sides of the equation. So the 4t is going to end up over here, and the 3 is going to end up over here. Okay, so then I'm going to wind up dividing both sides by 4 to get t by itself. So this is basically going to give me the answer. Alright, now, but understand one thing. When we write what t is, like to put it in the calculator, we'll have to do a little change of base with this part up here. You know what, let me keep the colors the same for a second, to make sure no one gets lost in the sauce. So see this blue part up here? Change of base formula says we could write this as log 3 over log 1.01375. So in other words, I've got log 3 over log 1.01375. Okay, but all of that is over 4. Okay, like a bigger fraction with a 4 in the denominator. So this is what we have to do to find t. Now, I am very comfortable with making a fraction inside of a fraction. Alright, I can make this large fraction, the one that has a denominator of 4, okay, with this as its numerator. I can do that no problem. I just make sure that the denominator is 4, and then in the numerator I put an additional fraction. So here I have my log 3 business and my log 1.01375. Yeah. So I can just hit enter, and there you go. 20.11. Okay, to say nearest hundredth. Yeah, so we're talking about years here. So 20.11 years. Now, some students are not comfortable with the nested fraction, or they just plain do it wrong. So if you're one of those people, then what you could do is do the log part first. Do your log 3 over log 1.01375 and get an answer. But don't round this, alright? Because then you know you have to take that and divide by 4. So now you can just go divided by 4. And there's your 20.11. Alright, whichever you prefer. Okay, so that's it. That's the answer. Okay, how long? It just says how long, so that just means t. Alright, let's move on. So number 17. You deposit $5,000 into an account that earns 4.3% interest compounded continuously. As soon as you see continuously, you know we're using the PERT formula. Okay, so let's do that. So as far as the model for the investment, the amount we will have at some time later is equal to, now P is the principal, that's your initial amount, that's your $5,000. Okay, and then it's e to the RT power. So I'm going to always have this e. Now, as a decimal, this would be 0.043. So that's the R. So I'm going to have my 0.043 and then T because it's the model. Okay, now for part B, how long will it take for your investment to double? If we started with $5,000, of course, if our investment doubles, we will have $10,000. So I'm putting the 10,000 in right there. So that means 10,000 equals 5,000 e to the 0.043 t power. So next, to solve this, we would divide both sides by 5,000. So of course we're going to get 2. Alright, because we said how long for it to double. So of course it's going to be 2. So 2 equals e to the 0.043 t power. Next we want to rewrite this in log form. Now normally we would write log and then the base, and then these two parts will change sides of the equation. So I'd have my 0.043t over here, and I'd have the 2 over here. However, you don't write log base e, silly. That's your natural log. So we just write natural log 2 equals 0.043t. So we're solving for t, so all we have to do now is divide both sides by 0.043. So that gives us t equals whatever this is. So we've got natural log 2 over 0.043. So that is 16.12. Got to round up. Okay, so that is it for number 17. Now, number 18. Maine had a population of 1.2 million, which is 1,200,000 people in 1995. Since then, the population has increased at a rate of 1.3% each year. Write a model to estimate the following information. Okay. So, for my model, first of all, I need to decide like which one of these equations I'm dealing with. This does not sound like compound interest to me. So it's going to be one of these two. Alright, growth or decay. Okay, since then the population has increased. So the model we're using is the one that goes y equals the original amount times 1 plus the rate to the power of time, alright, the growth model. So in this case, the population is going to equal the initial amount, which is 1,200,000, alright, times 1 plus the rate. Alright, the rate is 1.3%. So as a decimal, that is 0.013. So I'd have 0.013. Now 1 plus 0.013 is simply 1.013. So we would be absolutely silly not to put that together. Alright, to the power of time. So please leave this as t for the model, because it's supposed to work and give us the population for any year we want. Okay, now, what is the current population in 2015? So, well, this model, this 1,200,000 was in 1995. In 2015, how many years have passed? That's 20 years. All right, so t is going to be 20 for this calculation. All right, so if we basically use this and let t be 20, okay, let's see how much of this I can remember. It was 1,200,000, 1.013. All right, to the 20th power. Now let me just look back and make sure. Okay, so this would be our population in 2015. So let's see. All right, just putting those commas in the right place, right? So this is 1,553,711 people. I'm going to round to the nearest whole person. 1,553,000. Hold on, it's not letting me go. $711. Okay, great. When will the population reach this number? All right, 2,500,000. Well, basically, they're saying, let's plug in, hold on. If we put in this number for the eventual amount, we have to solve for time. Okay, so that would look like this. 2,500,000 equals 1,200,000 times 1.013 to the t power. Okay, so we would first divide both sides by the 1,200,000. Okay. Just to make my life easier, sort of shortcut wise, all these zeros, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All right, it'd be the same as having 25 over 12. Okay, so that's this number. Actually, I think I'll just leave it as 25 over 12 for right now. Okay, so I've got 25 over 12 is equal to 1.013 to the t power. Now, to get this t that's in the exponent, I need log form. So this would be log base 1.013, and then this and this will change sides of the equation. So the t is going to come over here, and I'll have my 25 over 12 right there. So I'm going to put this in my calculator, but I have to do log this divided by log that. So I'm going to have to do log 25 over 12, okay, over log 1.013. Okay, so that is 56.83 years. Okay, so that's how many years we're talking about. Now, if I wanted to know what year that would be, 1995 okay, that's going to take us into the year 2051. Alrighty then. Alright, how many more of these we got? Okay, 2 more problems. This video is getting a little long. You buy a car for this much money, the value decreases by 12.5% each year, write a model. Okay, so we are going to use the general decay model. So that's going to be y equals, alright, and it's going to go 1 minus the rate to the power of time. Okay, the rate is this 12.5%. However, we will move the decimal point twice, so that'll be as a decimal 0.125. So I have 1 minus 0.125 to the t power. Okay, it's good form to go ahead and do this subtraction. Okay, 1 minus 0.125 is 0.875. Alright, so it's good form to write this as, oh wait, I left off the initial amount, didn't I? I'm going to have to fix that. 0.875 to the t power. Yeah, the model, you always have to include the initial amount as in front of here as the coefficient. So the model is y equals 24,000 times 1 minus 0.125 to the t power. Okay, or this. Alright, now, when will the car be worth half of its original price? Well, half of its original price means $12,000. Okay, so we'll have 12,000 equals 24,000 times, and I'll use the 0.875 version. Okay, so when is the t that we are looking for? So obviously if we divide both sides by this 24,000, of course we're going to get 1/2, alright, because it's half of its original value. We set it up that way. So this is going to be 1/2 equals 0.875 to the t power. So to solve for this exponent, we need log form. So this will be log base 0.875. And then these two things are going to change sides. So the t will be over here and the 1/2 will be right here. Okay, so to put this in my calculator though, I need to do log 1/2 over log this. Alright, so that's 5.19 years. And that's the answer number 19. Alright, last one. You make a deposit into an account that is compounded continuously for 15 years. Okay. So, the thing that we don't know is the rate. So as far as the model goes, then our eventual amount is going to equal the initial amount Okay, as soon as we saw continuously, we knew we were using the PERT formula. Alright, that's the one for continuously compounding. So there's our principal, is our 1,000. Now we'll need E. Now the rate we don't know yet, but this time we're told the time is 15 years. So our RT will become 15R. Alright, so we'll just have to leave R in our model. Now if you want to have, instead of $1,000, if you want to have $10,000 after this 15-year period is over, what interest rate must the account have? So we're solving for R. Okay, so this 10,000 is what we want eventually, so that goes here on the left. So we will have 10,000 equals 1,000 e to the 15r power. So if we divide both sides by 1,000, okay, then this is going to make 10. So I have 10 equals e to the 15r power. So we just need to solve this for r. The way to go is to rewrite this in log form. Now normally we write log and then the base, and then these two parts of the equation change sides. So I'd have my 15r over here and I have my 10 right there. But you don't write log base e. That's crazy. Alright, that's natural log. So instead we write natural log 10 instead of writing log base e of 10. Okay, it makes it a lot easier to type in the calculator as well. So if I want this rate, all I have to do is to divide both sides by 15. So that's going to give me r equals natural log 10 over 15. Okay, so that is 0.1535. Notice how I use 4 decimal places. Okay, we are expected to write that rate as a percent. That's why we needed 4 decimal places, because when you convert it to percent, 15.35%. Now I only have 2 decimal places, so make sure you keep all 4 decimal places until you get to this step. So this is the rate that we would need, 15.35%, in order to have $10,000 after 15 years. That would be quite a nice interest rate to have, by the way. That's hard to get. Alright, anyway, that is the end of this lesson. I hope these videos have been helpful to you. I will see you guys on the next topic.